All right, multiplying integers. If you want to multiply integers, they have to have the same base. So up here we have a formula. The base is x and x, so that's just some number that's the same. When you multiply integers, we add the exponents. So you could be the same. So we're multiplying the bases, but you actually add the exponents. So I will explain this as we get into our problems. So if I have 2 to the third times 2 squared, let's just think about what that would be. 2 to the third means 2 times 2 times 2. 2 squared is 2 times 2. Now look at that. How many 2's are there in all? 5. So what I could do is just take and add 3 plus 2. And I can write it in exponential form, 2 to the 5th. So when we ask you to write it in exponential form, you're just adding the exponents and writing as 2 to the 5th. If they ask you to evaluate, that means they want the answer. So the answer evaluated means I'm actually going to multiply all those 2's. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 would be 32, and that would be the actual answer evaluated. So you're going to be asked to do 2 different things with this lesson. One is to be able to come up with this in exponential form, and one's to be able to come up with the answer evaluated. So if you see the word evaluate or evaluated, however it's worded, that means they want the final answer. If it says to write it in exponential form, they're looking for this. Okay? So let's take a look at the next one. If I have 3 times 3 squared, I'd have 3, and then 3 squared would be 3 times 3. How many 3's do I end up with?
3.
3. So I'm going to have 3 to the third. Well, that's interesting because this 3 doesn't have an exponent. So how are we coming up with a third?
Because it's just there.
So what exponent could I put on this 3? 1. So this would be the same thing as having a 1. And so it's 3 to the 1 plus 2. And that's how it's coming out to be 3 to the third. So if you have a number and it doesn't have an exponent on it, it is implied that you will know that the power on that number is 1. Question? Yeah. Okay, so if I'm evaluating this, I'm going to take 3 times 3. I get 9 times another 3. What's 9 times 3? 27. That's the actual answer evaluated. Okay, so this is all fine and good if your exponents are positive. But as we learned in the last lesson, we sometimes have negative exponents. We need to understand what they are, and we have to understand how to work with negative numbers, which we did in 6th and 7th grade. So if we go down, we're going to review first how to do integer addition. We did several different lessons. We had spiders and worms. We had red chips, black chips. We tried using number lines. There's a lot of ways to think about this. I'm just going to review this a little bit. If I'm adding negative 3 plus 5, we represented negative numbers with red chips, so that would be negative 3 would be 3 red dots, and then positive 5 would be 5 black dots. And we talked about a positive and a negative cancel. So those 2 cancel, those 2 cancel, those 2 cancel, and this is what I'm left with. So if I have 2 dots that are black that are left over, what is that?
Positive 2.
Positive 2. Okay, so if I come over here to this one, if I have negative 8, it's like having 8 little red dots. I know, you guys got this down last year, but I'm just making sure before we move on that we remember this lesson. So 4 black dots, 8 red dots. So these 4 black dots cancel out 4 of the reds, and I'm left with 4 red dots, which means my answer is negative 4. And then on the last one, everything's negative. So if I have 4 red dots and add 7 red dots, 1, 2, 3, 4, 5, 6, 7, nothing cancels because a negative can't cancel out the negative. I just get more negatives. I now have 11 red dots or 11 red chips, and my answer would be negative 11. You're just adding the same type of thing together. So do you guys remember doing this?
Yes.
This you have to know how to do in order to do the exponential form down here, because we're going to be adding the exponents. So if I have 5 to the negative 2 power and 5 to the 3rd power, what I'm going to do is I'm going to add negative 2 plus 3. What is negative 2 plus 3?
1.
Be 1. So my exponential form would be 5 to the 1st. And if I evaluate that and get the answer, what is 5 to the 1st?
5.
Just 5, a regular 5. So this is exponential form. This is your final answer.
So what we're doing on the negatives is just an extended chips method. Because the exponents are the chips.
Yes, chips. I thought for a second you said yes. Yes, so basically we're using what we learned the last 2 years and applying it to exponents.
Oh, that's
Yes.
easy.
Okay, so down here, I have 6 to the negative 1 and 6 to the negative 1. So I'm going to have 6 to the negative 1 plus negative 1. So that'd be a red chip and a red chip, and nothing would cancel. I just have 2 red chips, which means that this power would be 6 to the negative 2. This is exponential form. Now, on your worksheet, it's not going to let you leave your exponential form with negative exponents. So I'm going to show you how we can write everything with positive exponents. So 6 to the negative 2 is the same thing as 1 over 6 squared. We talked a little bit about how this does reciprocals. On your exponential form, this is what I want you to get to for that. They want all of the exponential forms to eventually end up as a positive exponent, because you have to do that to figure out the final answer. Because then down here I'm going to have 6 times 6, and we get 36 in the denominator. Some of us struggled with that on the worksheet that I graded last night. You flipped it over and did 1 over 6 times 6, but then you told me it was positive 36 with no fraction. If there's a negative power here, it's going to flip a whole number to make a fraction. If it's a fraction, it's going to flip it to make a whole number. So when you have those negative exponents, it does do reciprocal. So this is what I'm looking for here. This is what I'm looking for here. All right, so on the next one, we've got negative 5 and 1 for the powers. And this only works when we have the same base. It all has to be 4s or you can't combine them. So I'm going to have 4, and I'm going to add negative 5 plus 1. So what's negative 5 plus 1?
Negative 4.
Negative 4. So I'm going to have 4 to the negative 4th power. But Mrs. Phillimore says we can't leave it as a negative exponent in our exponential form. So 1 over 4 to the 4th. Good. So 1 over 4 to the 4th. Make sure it doesn't look like 44. Make the other 4 little. Make it raised. And then we have to do 4 times 4 times 4 times 4. So if you think 4 times 4, that's 16. And then you have another 4 times 4, so 16 times 16 is how much?
256.
256. And so that might take a little bit of work to come up with. Some of the numbers will be big, but that's my final answer. We just took 4 times 4 times 4 times 4. And you could do 4 times 4 is 16, times 4 is 64, times 4. And you can do the repeated multiplication by hand. You could use a calculator. But the big thing is, this is what I want for the exponential form. This is what I want for the final evaluated answer. Okay, so then the very last one, I have 7 as the base, and we have negative 3 and 3, so we're going to add negative 3 plus 3. So it's going to be not just 7, be 7, what would be the power?
0.
To the 0 power. So that's my exponential form. And then I have to know the rule. If it has a 0 power, the answer is just 1. So that's why we talked about negative powers and 0 powers before we hit this.